Hey everybody, we're going to talk about least common multiples here. This is section 4.7 in your book. First off, let's talk about multiples. So there you see the definition of a multiple. It's a product of that number and any whole number. So for example, the multiples of 2 and 5. So 2 times 1 is 2, 2 times 2 is 4, 6, 8, 10, 12, 14, 16, 18, 20, and that pattern continues. Look at the multiples of 5. 5, 10, 15, 20, 25. That pattern continues. Now, what we can find is common multiples. So a multiple of 2 that is also a multiple of 5, well, 10 is a multiple of 2 that is also a multiple of 5. 10 and 10. What's another? 20 and 20. So the least of the non-zero common multiples of 2 or more numbers is called the least common multiple. So the least common multiple here is what? 10. 10 is a common multiple between 2 and 5, and there is not a common multiple smaller than 10. Now, we can find the least common multiple of 30 and 36 one of two ways. One way is to list the multiples. I've already listed the multiples of 30 out. So let's do this now and list the multiples of 36. 36, 72, 108, 144, 180. And as I write 180, I see I have a match. 180 and 180. So my least common multiple here is LCM of 30 and 36 is 180. Take a moment now, pause the video. I want you to find the least common multiple of 24 and 15 by listing out the multiples. Pause the video now. Okay, so I've listed out the multiples of 24 and 15. As I was listing out the multiples of 24, 24, 48, 72, 96, I knew if it was going to be a multiple that was also a multiple of 15, it had to end in a 0 or a 5. So this ends in a 4, an 8, a 2, a 6. And when I got to 120, I said, let me stop there and let me check out the multiples of 15. So 15, 30, 45, 60, 75, 90, 105. And then sure enough, 120 shows up. So 120 is the least common multiple. There we go. Now we have another method of finding the least common multiple. And that method is this. We can find the prime factorization of these numbers. So that looks like this. 30, we're going to make a factor tree. 2 times 15. 15 is 3 times 5. Okay, so let me write that out. This is 2 times 3 times 5. That is 30, the prime factors of 30. 36, this is 2 multiplied by 18. 18 is 2 multiplied by 9, and 9 is 3 multiplied by 3. So we've got 2 multiplied by, I'm going to throw the 3 under here because we are going to be looking for a match, right? So I use that 2, I use that 3, and then times 2 times 3. So we want to work this similar to GCF, but there's some difference as well. So I've got a pair of 2's, so I'm going to write down 2 once. I've got a pair of 3's. I'm going to multiply by 3, so write down 3 once. But then all this other junk left over here, the 5, the 2, the 3, I'm going to multiply by all that as well. So times 2 times 3 times 5. So when we multiply all this together, 2 times 3 is 6. 2 times 3 is 6. So this becomes 6 multiplied by 6 multiplied by 5. 6 times 5 is 30. 30 times 6 is 180. So when you multiply all that together, you get 180. And we've already worked the LCM of 30 and 36. And we got 180 earlier. So it checks out using this method as well. Again, you make your factor trees, which you've done plenty of times. I lined up my matches, 2 and 2, 3 and 3. Those are the only matches I had. Because I have a match of 2, I copy that down once. I have a match of 3, I copy that down once. And then everything else that is unmatched, it gets copied down. So a 2, 3, and a 5. Multiply all that together, and that is your LCM, your least common multiple. This has a great application, by the way, when it comes to finding common denominators in fractions. And we'll get to that in a bit here. But right now, I'd like you to practice using that same method of the factor tree. Pause the video now and find the LCM of 18 and 12. Pause the video now. All right, so here I have my factor tree of 18 and 12. 18 is 2 times 3 times 3. You'll see that up top here, 2 times 3 times 3. 12 is 2 times 2 times 3. So 2 times 2 times 3. I've got a pair of 2's. So I'll copy that down once. I've got a pair of 3's. I'll copy that down once. And then all this other stuff gets multiplied as well. So a 3 and a 2 is what's left over. So times 3 times 2. So there you go. 2 multiplied by 3, that is 6. 3 multiplied by 2, that is 6. 6 times 6, you should have gotten 36 for your LCM of 18 and 12. Now this is a little different. We're going to find the LCM when we have variables involved. Okay, so we're going to use the exact same method we did a moment ago. Factor tree of 12. 2 multiplied by 6. 6 is 2 multiplied by 3. There are my prime factors. 8, factor tree again. 2 times 4. 4 is 2 times 2. Those are those factors there. So let's focus on the 12a squared b. So 12, we just found out, is 2 times 2 times 3. But we have some other stuff here too. We have a squared. That is a times a. And we have a b, which is just going to be multiplied by b. Okay? So there's the prime factorization of 12a squared b. 8ac, we did the prime factorization of 8. That is 2 times 2 times 2. A, that's just going to be multiplied by A times C. There you go. So now if you remember what we just did, we want to look for pairs. So I got a pair of 2's. Write that down once. Multiply by, I've got a second pair of 2's. Write that down once. Do I have any more pairs? I've got a pair of A's here. So A's, that gets copied down once. Now there's a lot of other stuff that does not have a match. 3 and 2, A and C, B. So all this other stuff gets copied down. Multiplied by 3, multiplied by 2, multiplied by A, multiplied by B, multiplied by C. So now we just multiply everything together. 2 times 2, that is 4. 4 times 3, that is 12. 12 times 2, that is 24. Let's check that one more time. 2 times 2 is 4. 4 times 3 is 12. 12 times 2 is 24. What about A times A? A times A, that is A squared. B, there's only one B, so just B. And then C, there you go. So our LCM here is 24 A squared times B times C. So following the same method, factor tree, factor out all these squares as well and all the exponents like we did here. A squared is a times a. We'll look for pairs and then multiply everything together. Find the LCM of these two. Pause the video now and do that. All right, so here's what I did. 10, prime factorization of 10 is 2 times 5. So you'll see 2 times 5 up here. X squared times y squared. That is x times y times y. 6x cubed times y, 6. The prime factorization of that is 2 times 3. So 2 times 3 is there. Times x times x times x times y. Now we look for pairs. I got a pair of 2's. I've got a pair of x's. I've got another pair of x's. And I've got a pair of y's. Copy down all the pairs only once. That's 2 times a pair of x's, another pair of x's, and a pair of y's. And then everything else that's left over that is not circled gets copied down too. So times 5, times 3, times y, times x. And now we just multiply all this together. This is a little jumble, but we can do this. Let's see here. So we've got 2 times 5, which is 10. 10 times 3 is 30. X times x is x squared. X squared times x is x to the power of 3. Right? 3x's is x to the power of 3. Y times y is y squared. So there you go. 30x cubed y squared. Let's try one more and that'll be the end of this. Let's jump to that one. Pause the video. Find the LCM of these three. All right, this looks like a jumbly mess. So here's 12. That factors out to be 2 times 6, 2 times 3. So 2 times 2 times 3. You see that right here, 2 times 2 times 3. And then x to the power of 2 times y. That's x times y. 15, that is 3 times 5. So 5 times 3 is what I did because I wanted to line up those 3's. And then x times z, so xz. 16 is 2, 2, 2, and 2. So you'll see those 4 2's there. And then x times y squared, y times z to the power of 3, z times z times z. Now, here's where it gets a little confusing. It doesn't have to show up. The pairs don't have to show up. The matches don't have to show up in all 3 of these. Just showing up in 2 is enough. I know this is confusing, but just showing up in 2 is enough. So we have 2 and 2 showing up here. So I'm going to write down a 2. I have 2 and 2 showing up here and here, 2 and 2. So I'll multiply by 2 again. I have 3 and 3 showing up there. So I'll multiply by 3. Now here I have x, x, and x. So all of those get circled. And I multiply by x just once. I've got y and y showing up here and here. So I multiply by y. And I multiply by a z and a z showing up there and there. That's just one z. So let's double check this. 2 and 2, so I got a 2 written down. 2 and 2, I got a 2 written down. 3 and 3, I got a 3 written down. 3 x's, so I got 1 x written down. Y and y, I got a y written down. And z, so I got a z written down. Now everything that's left over that is not circled, also we're going to multiply by that. So let me slide to the left here. So I've got 2, 2, and 5. 2, 2, and 5. And then my variables, I have x, y, and z. So x, y, z, and z. Okay, now we multiply all this together. 2 times 2 is 4. 4 times 2 is 8. 8 times 2, we get 16. Okay. 16 times 3 48. All right, now 48 times 5, I'm not sure what that is, but I know 48 times 10 is 480, right? 48 times 10 equals 480. So half of that is going to be 48 times 5, which is 240. So all this is 240. That was the hard part. The easy part now, x times x. What is x times x? X squared. And then we have y times y, which is y squared. And then z times z times z, which is z to the power of 3. There you go. I know that was not easy. That was the least common multiple. One more time. Factor trees, we look for pairs or even 3 of a kind like we have here with x, x, and x. Anytime you have a pair or a 3 of a kind, it gets written down only once. And then all the other numbers that are not circled get written down as well. And all of that is multiplied together to find your least common multiple. All right, I'll see you tomorrow.